Winter conditions demand speed, and this foundation cannot afford to sit exposed. The builders start with a structural insulated panel floor, locking each massive section together with heavy-duty adhesive foam. This expanding polyurethane seals out the freezing ground drafts before the walls even go up. Unlike traditional stick framing, these prefabricated panels combine structure, insulation, and the subfloor into a single continuous layer. The foam acts as both a permanent chemical bond and a thermal break. It ensures that ground moisture and freezing temperatures stay firmly locked out. The transition from horizontal platform to vertical envelope happens immediately. Lifting the first exterior panel establishes the plumb line for the entire perimeter. The saw work here isn't just for length. It ensures tight dimensional tolerances where the corners meet. A minor deviation at the base multiplies into a massive gap by the roofline. Accuracy here dictates the structural integrity of the whole frame. Pneumatic nailers secure the base plates directly through the panel skin and into the joists below. This anchors the walls against high wind loads. The wooden splines inserted between the panels act as a hidden skeleton, transferring stress evenly down into the foundation. It creates a continuous shear wall system capable of withstanding severe lateral forces. Every nail point locks the geometry tighter. As the perimeter takes shape, the sheer weight of these solid core panels becomes a factor. Moving them requires careful balance, but their size means the walls close in rapidly. The expanding foam is applied to every vertical seam before the sections are married together. This eliminates the microscopic air gaps that plague standard fiberglass insulation. The result is a nearly airtight outer envelope. Over the next phase, the layout demands larger, unbroken sections. Maneuvering these full-sheet panels through the deep mud takes physical endurance. They must remain perfectly vertical as they are levered into the floor track. The foam core construction provides immense rigidity, turning what looks like a simple board into a load-bearing column. Solid timber beams are driven into the recessed edges of the panels, locking the adjacent sections together. This timber spline connection method prevents the walls from racking or twisting under pressure. Liberal application of adhesive along these joints is crucial. Once cured, The polyurethane foam creates a chemical weld stronger than the surrounding wood. The barrier becomes completely seamless. Temporary staging platforms allow access to the upper seams, where leverage is hardest to apply. Fastening the panels tightly against the timber splines requires high-torque drivers to pull the layers flush. Any bowed sections must be wrestled into perfect alignment before the adhesive fully sets. The window rough openings emerge naturally as the modular panels interlock. The shell is rigid. Framing around the rough openings requires specific header panels to bridge the gaps. These smaller segments distribute the roof weight away from the glass that will eventually fill the space. If the headers sag under compression, the future windows will bind and crack. The builders constantly verify the level and plumb lines across the entire elevation. Every section relies on the true geometry of the last. A perfectly square frame prevents expensive headaches during the finishing phase. With the perimeter enclosed, a continuous top plate is tied into the upper edges of the walls. This horizontal band distributes the massive downward pressure of the upcoming roof system evenly across the panels. The team secures the headers with pneumatic framing nailers, driving long fasteners through the top plate and into the solid splines below. Expanding foam seals the final upper joints, leaving the exterior shell fully integrated. The outer defense is complete. Focus shifts from the insulated shell to the interior skeleton. The interior load-bearing walls are framed traditionally with dimensional lumber. Cutting and assembling these sections flat on the foundation slab ensures the base plates remain perfectly flush. The craftsmen measure the stud spacing to directly support the overhead ceiling joists. This internal framework won't simply divide the living spaces. It will carry a significant portion of the roof's snow load. Working indoors out of the wind, the assembly pace accelerates. Every precise cut guarantees a tighter structural fit. The assembled wall frames are tilted up into their final vertical positions. Lifting these heavy green lumber sections requires coordinated effort and careful footing on the raw floor. Once raised, they are locked into the exterior SIP walls, bracing the entire structure internally. The network of wooden studs acts like the ribs of a ship, preventing the wide exterior spans from flexing under high wind loads. The floor plan finally reveals its true physical scale. A secondary top plate is added over the raised walls, overlapping the joints where the sections meet. This interlocking layer ties the entire interior layout together into a rigid, unified grid. The pneumatic nailer sinks heavy framing nails at precisely angled trajectories to prevent the wood from splitting while maximizing pull-out resistance. The structural integrity of the roof hinges on these intersecting beams. They must hold perfectly steady. Before the massive ceiling joists are set, a continuous bead of foam is laid along the top plates. This step prevents air infiltration between the wall and the roof structure. The heavy overhead beams span the width of the house, tying the outer walls to the central load-bearing spine. Moving these long, unwieldy timbers by hand demands careful balance and clear communication. Power drills drive massive structural screws, pulling the heavy joists tight against the top plates without the risk of backing out over time. A heavy hammer helps persuade the stubborn timbers into perfect alignment. When the hardware bites into the dense grain, the connection becomes permanent. The ceiling plane is now established. The final interior supports are locked into the grid. Short blocking pieces are hammered between the long vertical spans to prevent the studs from bowing or warping as the green lumber dries. These blocks also create solid anchor points for future drywall installation. The pneumatic nailer speeds up the repetitive fastening, but heavy blows are still required to sink tight-fitting structural blocking. The skeleton is now rigid, reinforced, and ready to take the weight of the roof. As the crew moves upward, the exposure increases. The roof decking begins with custom-cut wooden panels fitted directly over the rafters. Cutting material at this height introduces severe wind factors and limits mobility. A circular saw bites through the heavy composite boards, sizing them to stagger the seams across the roof plane. Staggered joints prevent a continuous weak line that could compromise the deck under heavy snow accumulation. Precision is vital, as any gap will telegraph through to the final metal roofing. Specialized adhesive tape seals the panel seams, creating an unbroken wind and moisture barrier before the outer roofing is even applied. Long structural screws are driven deep into the rafters below, providing incredible shear strength to the roof deck. Unlike nails, which can slowly pull loose over decades of thermal expansion and contraction, these heavy-duty screws permanently lock the panels into the frame. The oriented strand board provides a solid, walkable substrate for the complex layers to come. A second story begins to emerge above the main ceiling plane. Framing this upper section directly on the pitched deck requires exact geometry. The builders use the flat expanse of the newly laid OSB to construct the short vertical knee walls before lifting them into place. Building flat and tilting up is faster and safer than trying to plumb individual studs on an angled surface. The pneumatic nailer anchors the bottom plates squarely into the structural beams below, tying the new elevation firmly to the home's core structure. The attic space is now fully defined. The main roof rafters are hoisted up to meet the central ridge beam. The angle of these heavy timbers dictates the pitch of the roof, a critical defense against heavy winter snowfall. Every rafter must be meticulously leveled and plumbed before it is permanently driven into the ridge block. Even a half-inch deviation at the peak translates to a massive warp down at the eaves. Cordless drills drive thick fasteners through the intersecting angles, locking the pitched skeleton together. The geometry of a traditional pitched roof distributes thousands of pounds of dead weight seamlessly into the exterior walls. The steep triangular gables are sheathed in structural-oriented strand board, sealing off the upper attic spaces from the severe wind. Working from ladders, the crew carefully maneuvers these awkward, sail-like panels into position against the high rafters. Down below, heavy timber base plates are bolted directly into the concrete foundation pillars. These plates create a solid anchor for the exterior cladding and finish work, bridging the gap between the engineered floor platform and the raw earth below. The house is firmly rooted. With the structural shell complete, doorways are carved directly out of the continuous wall panels. A chainsaw plunges into the thick insulated core, biting through both layers of OSB and the dense foam between them in a single pass. Cutting openings after the walls are erected guarantees that the framing remains perfectly rigid during a... An axe makes quick work of any jagged wooden splinters, leaving a clean, rough opening ready for the final door jambs. The entire structure is wrapped in a high-tech synthetic moisture barrier. This membrane is highly engineered. It blocks liquid water and freezing winds from penetrating the wood while remaining entirely breathable to let interior water vapor escape. This prevents condensation from rotting the frame from the inside out. Up above, the roof decking is trimmed back to leave perfectly straight, uniform overhangs. These eaves will protect the freshly wrapped siding from driving rain. The house is taking its final defensive posture against the environment. High on the wooden scaffolding, the final complex sections of the roof structure are tied into the gables. Lifting the heavy rim joists into position at this elevation tests the limits of raw balance and grip strength. Every structural rafter is screwed firmly into the underlying plates, transferring the immense weight of the overhang back into the vertical walls. The crew moves carefully across the exposed framework, pulling electrical cables and securing the last of the structural ties before the roof is sealed. A dropped tool or a misstep here halts the progress entirely. The exposed wood is now heavily reinforced, ready to bear the final steel armor. A specialized silver-backed vapor barrier is unrolled across the open rafters. This reflective membrane serves a dual purpose. It sheds any condensation that forms under the metal roof, and it reflects radiant heat away from the living space during summer. The material must be pulled drum-tight. Any sag would allow dangerous moisture pools to form. Over the membrane, a grid of thin wooden battens is nailed horizontally across the rafters. This batten grid provides the crucial air gap required for proper roof ventilation while serving as the direct anchoring point for the corrugated metal sheets. Inside the sealed attic, a chainsaw forcefully cuts a permanent access hatch, raining white insulation dust down onto the floor. The layers are nearly complete. Custom metal drip edges are nailed onto the perimeter battens. This angled trim forces heavy rainwater to break cleanly off the edge of the roof, preventing it from curling back under the shingles and rotting the wooden fascia boards. With the edges armored, the massive corrugated steel sheets are hoisted up the slope. The deep channels pressed into the metal give it incredible rigidity against heavy snow loads, transforming thin steel into an impenetrable shield. The apex of the roof is sealed with a continuous metal ridge cap, overlapping the corrugated sheets on both sides to prevent driven rain from breaching the peak. The installer drives self-tapping screws equipped with neoprene washers. As the screw tightens, the rubber compresses, creating a watertight seal around the puncture. Lower down to the slope, heavy steel snow guard brackets are bolted into the structural battens. In deep winter, these simple metal stops will prevent tons of accumulated snow from shearing off the roof in a single destructive avalanche. The roof is now fully armored. Attention shifts back to the ground level, where a heavy timber porch is framed directly into the outer wall. These thick posts and diagonal braces anchor the entryway, softening the severe lines of the main structure. Inside, the final ceiling panels are driven flush against the upper joists. Spray foam insulation is injected deeply into the perimeter gaps, expanding to seal off the remaining thermal leaks. What began as a pile of prefabricated panels on a frozen, muddy lot is now a fully sealed, high-performance thermal envelope. In the end, a house is simply a machine for surviving the elements, built layer by layer to protect the life inside.